Okay, all right, so the recording has started. So like I just said, this is the final exam review for the full semester, the 16-week online statistics course. There are 60 questions on this review. Um, it's going to take us more than an hour to get through those 60 questions. I know originally these reviews were scheduled for an hour, but you guys might have noticed that they tend to be a bit longer. And this one is 60 questions, so we're going to be here for a while. So if you need to hop off and then come back on later, you have other things to do, or if you can watch part of it and then you have to leave for the rest of it, I will be emailing you a recording of it afterwards. Um, uh, I will do that today before I leave, so you'll get it this evening. But yeah, it's going to be, we're going to be here for a bit, but we're going to go through all 60 questions. When I send you the link for the review, I'm also going to create a playlist of all of the reviews for the other chapter tests leading up to this one, so that you can, like, if you find that you're struggling with questions from certain tests, like certain chapters, you can go back and rewatch those reviews, and those links will all be in the same place for you there. I'm also going to try and attach all of the various, I think I had a handful of like handouts and like charts and stuff that I provided for previous ones. I'm going to include all of those as well, so you've got everything all in one email. All right, let me make sure I've got my calculator, got my water bottle. I might lose my voice before the end of this, but we will get through as best we can. Is the light not on? There we go. Okay. This is, it's so hard to do this at this campus because the desk is just not set up for this, but all right, let's go ahead and dive. Oh, also, if you've given me your email before, then I already have it. You're already on my list. I'll be sending you the link. If you've never given me your email before, then you can either put it in the chat or you can email it directly to me, either at brandy.horn@datonastate.edu or maxine.horn@datonastate.edu. Either one will get to me. All right, let's dive in. Okay, number one. Determine whether the variable is qualitative or quantitative and explain your reasoning. So it says the amount of money spent on CDs this year. So it is quantitative. When you hear quantitative, think quantity, like amount, right? Because amount of money is found by measuring or counting. If you have something that is qualitative, like a quality, that's going to be things like an attribute or attribute, or how do they word it? Characteristic, right? So if it's an amount, if you can count it, it's going to be quantitative. If it is a quality, like the color of something, then that's going to be qualitative. Okay. All right. Two, I'm going to zoom in just a little bit. We'll zoom out as needed. Text gets so small. Determine whether the data are qualitative or quantitative. The colors of automobiles on a used car lot, that's going to be qualitative because color is a quality, right? Okay. Okay, use the given frequency distribution to find several things: the class width, the class midpoint of the first class, and the class boundaries of the first class. Okay, so we don't want to forget all the stuff we learned at the very beginning of the class, right? Your class width is from your lower class to your, from your lower class limit to your next lower class limit. Okay, so it's how many do we have to add to this to get to this? Some people get confused and they think, it's how many is it from this to this, but it's from one to the next, from one to the next. You could even go on this side from one to the next. Okay, so we would say 3 minus 1 is 2. So that's A. A is 2, is our class width. I'll be able to see more of the page here. Okay, the next thing it asks for is the class midpoint just of the first class. So the class midpoint is, you can kind of think of it as the average of those two. Okay, so it is your lower class limit plus your upper class limit divided by 2. That is your class midpoint. Okay, so the average of these two. So in this case, we have 1 plus 2 divided by 2. So that's going to be 3 divided by 2. That's going to be 1.5. So our class midpoint, B, is 1.5. Okay, and then they want the class boundaries of the first class. Okay, so the class boundary is the number between here and here, right? It's how we get from the high end of one to the low end of the other one. So you can think of it as the average of those two, right? So let's find the upper class boundary of the first class first before we find the lower one. So we're saying, what's the number that's halfway in between this number and this number? It's kind of hard to see. Let me erase that. I feel like I drew on top of that number there. That's a 2 and that's a 3. Let me admit someone. Hi, Alexa, welcome. We are recording, just heads up on that. And then like usual, I'll be emailing recordings to everybody afterwards. So I think I already have your email, but if not, email it to me or put it in the chat. Okay, so we're going to find the number that is halfway in between the upper class limit of the first class and the lower class limit of the second class. So the number halfway between these two. And we do that by taking the average of them. So we add them up and divide by 2. So that makes sense, right? 2.5 is halfway between 2 and 3. Okay, so I'm going to make this just a little bit bigger. So we have 1 to 2 and we have 3 to 4, right? Okay, but 2.5, so that's halfway between here and here. Okay, but they also want the lower class boundary, right? So what we have to do is we have to say, okay, well, how far away was this boundary from the limit, right? Because remember, these are the limits, these are the boundaries, right? These are the limits, these are the boundaries. How far away was this boundary from the limit? Well, it was 0.5 away. If it's not something that you can do in your head, feel free to actually write it out. 2.5 minus 2 is 0.5. So the boundary is 0.5 away from the limit. So this boundary needs to be 0.5 away from this limit. So one of these less than that, or 1 minus 0.5, is going to give us 0.5. Right? So we go 0.5 to the left and 0.5 to the right. 0.5 to the left, and if they wanted us to, 0.5 to the right. But they were only asking for the class boundaries of the first class. So that's 0.5 and 2.5. Right, so that's how they're getting this. Our class width was 2, our class midpoint was 1.5, and the class boundaries of just this first class are 0.5 and then 2.5. Okay. Okay, so use the given frequency distribution to find, this time they want us to find the information for all of these, right? The class width, all the class midpoints, and all the class boundaries. Okay, so I'm going to do this just so it's a little easier to see everything. Oop, didn't mean to draw a line through the 7 there. Okay, so the class width, again, is from your lower class limit to your next lower class limit, or from an upper class limit to the next upper class limit. You can pick whichever one you want. I'm just going to do the first ones here. So I'm going to do 37 minus 32. That gives me 5. So that is my class width. Class width is 5. Okay. Now they want the midpoints. So the fastest way to do this is to find the midpoint of the first class and then add your class width to get to the midpoint of each class after that, right? So the midpoint of the first class is, I take the average of those two numbers, right? I add them up and divide by 2. If you can do it in your head, depending on the numbers that you have, great. If not, feel free to use a calculator. Okay, so this is going to be 68. So that's going to be 34. So 34 is, and I'm going to write the midpoints over here. Okay, so the midpoint of that first class is 34. And now what I'm going to do is I'm going to add my class width, which is 5, to that to get the next one, right? Oop. So in my calculator, I'm going to go 34 plus 5, enter. So that gives me 39. And then I'm going to do plus 5. I don't have to type second answer. I can just do plus, and it's like, oh, I assume you want to take the answer and add 5 to it. And hit enter. And that gives me 44. And then I'm going to do that one more time where I say plus 5. And by the time I've done that 3 times, the calculator understands this pattern, and I can just start hitting enter. So I'm not going to hit plus 5. I'm just going to hit enter. And it says, oh, you want to keep doing the same thing that you've been doing the last 3 calculations. You want to add 5. And then I hit enter again. And then I hit enter again. And as I do this, I want to stop and make sure that these numbers make sense as the midpoints of these classes, because maybe I plugged something in wrong, right? Like maybe I did this calculation wrong, or maybe I did the class width wrong and I'm adding something that, isn't going to work. So every time that I do this, I want to say, okay, does it make sense that 39 is halfway between 37 and 41? Yeah, that sounds about right. Is 44 halfway between 42 and 46? Yeah, that sounds about right. Right, so I'm checking each time to make sure that my answer makes sense in the context of the problem. All right, so I added 5, I added 5, I added 5, and that's how I'm getting all of these midpoints. Okay, and then they want the class boundaries, right? So, oh, sorry, I just realized the way that this is written is kind of weird. All right, I think, yeah, I just realized this is written weird. Oh, no, it's not. I see. I see. I thought it was like, oh, it's only giving you half of it, but no, it is. It's good. It's just, I mean, it is written weird, but anyway, okay, so now, just like before, when we found our class boundaries, we're going to do that again, but they want it for all of the classes, not just the first class. So again, to find the class boundary, you're going to do the number that is halfway in between your upper class limit of one class and your lower class limit of the next class. So I'm going to take the average of those two numbers if I can't just tell automatically what is halfway in between those. So I have 36 and 37, and that's going to be 73. Is that right? My brain is mush. Okay, yeah, it is 73. And when I divide that by 2, I get 36.5, which makes sense because 36.5 is halfway between 36 and 37. So what we've just done is we've realized that we are 0.5 away from the limit. So the boundary is either 0.5 higher than the limit or 0.5 lower than the limit, okay? So for this first one, 0.5 lower than the, well, let me write in what I have here. This is 36.5. And remember, for your boundaries, the boundary of one is exactly the same as the boundary of the next one below it, of the upper versus the lower. So the upper class boundary of one class is the same as the lower class boundary of the next class, right? So that's the difference between your, so small. That's the difference between your limits and your boundaries. So for your limits, there's no overlap, right? 36 is a separate and distinct number from 37, but for your boundaries, right? So these are your limits, your upper and lower limits, and then these numbers are your boundaries. You guys can't see that. So the boundary here is the same number as the boundary here, right? Okay, so now that we've established that it's 0.5 higher and 0.5 lower, we can just fill all of these in. Or another thing we could do is we could say, I'm just going to add my class width, right? So we can say just what's 36.5 plus 5. So again, I can do that at my calculator. If I don't want to say, well, what's 0.5 more than 41? I can just say, well, what's 36.5 plus my class width? That's going to be 41.5. Let's do this whole side, and then we'll do this whole side. And then I'm going to add 5 again. I'm going to add 5 again. And my calculator gets the point now, so I'm just going to hit enter. And it's going to continue that pattern. Enter. And enter. And again, I'm checking as I go. 46.5 is 0.5 away from 46. 51.5 is 0.5 away from 51. Okay. And now we're going to do the same thing over here. I have 36.5. I'm going to add the class width. 41.5. Or I can say, oh, well, the number's right there. So I'm just going to write it there. The number's already there. I'm just going to write it there. Number's there. I'm going to write it. The number's there. I'm going to write it, and the number's there. And I'm going to write it, and the only one that we have to worry about here is this one. So you could either say, I know that it has to be 0.5 less than the limit, or you can say, if I go in this direction, so if I go down, I'm adding 5. So if I wanted to go up, if I wanted to go in this direction, I would subtract 5. So I could say 36.5 minus 5. That's going to be 31.5. And we can check and say, well, does that make sense? Is that 0.5 away from that? Yes, it is. Okay. So that's how we would do that to get all of these numbers. Okay. Okay. All right. Give 3 observations that can be made from the graph, but they want specific ones. So they are saying site whatever has the most users. Okay, well, this is just a matter of looking at the graph and saying, well, what is labeled as what? So this axis, vertical axis, is the number of users. And this is showing us the different categories or which sites. Monthly active users on 5 social networking sites. So 5 different sites. They haven't labeled what they are. They're just calling them A, B, C, D, and E. So which site has the most users? Well, the one that corresponds to the highest rectangle, right? So that's A. Which site has the fewest users? Well, that's just going to be the one that corresponds to the lowest rectangle. That's E. And which sites have about the same number of users? That's going to be B and C. Not plus. Sorry, when I'm writing, I tend to use a plus sign for the word and, but I shouldn't use that in math. So these are about the same. I mean, C is similar, but not as close as these are to each other. So that one's just checking that you know how to interpret a graph, right? Okay. All right, so display the data to the right in a Pareto chart. Describe the difference in how the pie chart and the Pareto chart show patterns in the data. So I had to reprint this page because I had it in black and white, and I was like, oh, right, there's the different colors here. um, so the Pareto chart, they have to go in order, right? They have to be in decreasing order. So they can't go like like let's say you have, I mean, this one is seasons, right? Summer, fall, spring, winter. Um, that's in order if we started or actually, no, that's not in order. um, but they, excuse me, they can't be like in chronological order. They have to be in like descending order, right? So the largest rectangle has to go first, then the next largest, then so on and so forth. So they have to be put in descending order, um, uh, starting with the highest and then going down to the lowest. So we would look at the numbers. If you guys can even see those numbers. So summer is 36%. Okay. Fall is 21%. This is summer. This is fall. Spring. Oops. Writing my percentages first. 25% is spring and 15% is winter. Okay. So we start with the biggest number. The biggest number is 36. That's summer. So that's what goes first. Then the next biggest number is spring. So that has to go next at 25%. Then after that, we have fall. Then after that, we have winter. So they have to go in order. That's the Pareto chart. So, and then describe the difference and how they show patterns. The pie chart just shows the percentages as parts of the whole, and the Pareto chart shows the rankings, right? They're in order, they're ranked highest to lowest. Okay. All right. Okay, a misleading graph is a statistical graph that is not drawn appropriately. This type of graph can misrepresent data and lead to false conclusions. Explain why the graph is misleading and redraw it so that it's not misleading. So anytime you have these three-dimensional ones, many groups of people will misinterpret them. So I think that's a little bit subjective. Because you can certainly tell it which sort of section of the pie you want facing you, but a lot of people can look at that and see that the blue and the yellow are exactly the same. Hold on, let me admit this person into the room. Hi, Christina. Okay, just heads up, we are recording. Okay, so yeah, so I think I was just saying that like a lot of people can look at this and see that these two pieces of the pie are the same size, but for a lot of people, that's not as obvious. Because this is sort of front and center, to a lot of people, this looks like a bigger slice than this, even though they are the same size. So you do run into that potential confusion anytime you make these look 3D like this, where you're looking at, it's like a hockey puck, and instead of looking at it top down, you're looking at it like kind of from the front and side, right? So yeah, so that's what it's saying. It's saying that the angle makes it appear that the third quarter, which is this yellow one, has a larger percentage of sales, when in fact it's the same as the first quarter, which is the blue one. Okay, so then they want us to select which graph corrects the error, and that's going to be C. Now, the reason that it is C and not B is because we still need to go like in order here. This is the first, the second, the third, and the fourth, right? So we go clockwise here, first, second, third, fourth. Where with this one, it's going the wrong direction. It's going first, second, third, fourth, but it needs to be going clockwise, not counterclockwise. Oh, also, those are the wrong numbers. You should probably put the right numbers, right? That's not 20%, it's 38%. Right, the first quarter is 38%. So this one is wrong in multiple ways. And yeah, so we start with a pie. We should be consistent and stay with a pie. There's nothing wrong with a pie chart. We don't have to change it to a graph. It's better not to be this sort of three-dimensional thing here. Okay. All right, the top 14 speeds in miles per hour for professional drag racing over the past 2 decades are listed below. Find the median speed. What is the easy way to solve it without spending too much time? Are you talking about for number 7? Okay, so I guess just to clarify, when I explain it, I'm given the full explanation. You're not necessarily thinking through the full explanation. So for instance, if I was doing this question, I read the question, I look at the graph, I look at my potential answers. Okay, the area of the pie chart is more than 100%. Oh, let me check that. 38 plus 20 plus 38 plus 4. No, it's not more than 100, so that's not it. The data should not be displayed in a pie chart. No, that's not it. There's nothing wrong with displaying data in a pie chart. The angle makes it appear that the third quarter has a larger percentage sales when in fact it's the same as the first. Oh yeah, there we go. That one's the right answer. Which of the following graphs corrects the error? Well, I don't need to do a chart instead or a graph instead of a pie chart. I can absolutely do a pie chart, so I'm ruling that one out. And then I look at these and hopefully I would actually notice that the numbers are wrong before I notice that they're going in the wrong direction. I was just looking at the colors to start out with, that we have blue and then magenta and then yellow and then green is what it should be. But maybe I notice first that it's 20% when it should be 38%. So I rule that out and I select C. So that's kind of like, and I did it again though, because as I'm explaining what I would do here, I went into more explanation. I'm used to explaining to other people rather than saying like how I would do it in my own head. So I went into more explanation than I needed to there that second time around. But when you're doing it, you're just going through and saying, okay, which of these should I do? And to be fair, maybe for part A, I don't add them up before I actually just read through all my options, right? Generally, as a test taking strategy, don't do math before you've read all your options, right? Read the, hold on. Sorry, I'm already getting a dry throat. I did another review earlier today that was like 2.5 hours long, so my throat's already a little sore. But yeah, so test taking strategy, read through the whole question, then read through all the answers so that you can, potentially rule some of them out right off the bat. So, maybe as you go through and do this one, you don't even have to check if A is right, because by the time you get to C, you're like, oh yeah, C's the right answer. So, all right. Okay, and then for this one, they wanted us to find the median. Okay, so the median, remember that mean is the average, right? Add them up, divide by how many you have. Median is like that thing in the middle of the road, right? The median in the road is the thing in the middle of the road. So it is the number in the middle, which is not the same thing as the mean. I mean, sometimes they can end up being the same number, but they're not the same thing. Okay, so how do we find the median? So if you have just a handful of numbers, then you can rearrange them so that they're in ascending or, sorry, you said how about 6? Okay, hold on, let me go back to 6. Okay, so you said how about 6 was, sorry, what was your question about number 6? So it says display the data that's here in a Pareto chart. And the definition of a Pareto chart is that they have to go in descending order. So from highest to lowest. So we take these numbers here. Sorry, this was actually, I pulled this from a previous one that doesn't actually have all the notes that I put on there. Let's go back to the one. Right. So Pareto means that you have to put it in, you put it on a graph and you put it in descending order. So I just rewrote these percentages because I feel like this is really small and you guys probably can't see that. And then we went through and we said, okay, what's the highest number? That one goes first. Summer was the highest number at 36%, so that went first. Okay, what's the next highest? The next highest was spring at 25%. That went next. The next highest after that was fall at 21%. The next highest after that was winter at 15%. So you're kind of like you're creating it yourself, right? So kind of test taking strategies, I look at these and I say, well, that can't be it because they're not in descending order, and that can't be it because they're not in descending order. So I have to look at these two. So which one of these are in the right order? Well, this one has spring as the highest one, but spring's not the highest one. Spring's only 25%. Summer's the highest one. So this is not in the correct order. And then describe the difference in how the pie chart and the Pareto chart show the patterns in the data. We would just read through all the options and say, okay, so the pie chart shows the distribution of the seasons. The Pareto chart shows the individual responses. No, it doesn't show individual responses. It shows the total of the responses, so that's not it. The pie chart shows the individual responses. Neither of these are showing individual responses. That's not it. And then we read C and we say, oh, the pie chart shows the percentages as parts of the whole. Yeah, that's what a pie chart does. A Pareto chart shows the rankings of the season, rankings as in highest to lowest. Yeah, that's it. And then if we weren't sure, we would read through D and we would say the pie chart shows the rankings of the season. No, pie charts don't show rankings. So we would say C. Okay. All right. So okay, so this was asking for the median. So we're going to find the median. So we're going to put these in order. Sorry, hold on, let me get my other papers back in order here. Okay, so we're going to put these in order from lowest to highest, or you can do highest to lowest, whichever one you want. Well, no, actually, you really should do lowest to highest just to be consistent and to make sure that you're counting from the right section. Okay, all right, papers are back in order. So if I just had like a handful, like 5 numbers, I would just put them in order and I would just count like what's the one in the middle. But if you have more than just a handful, then you're probably going to have to do some math. So how you determine what is the median number. Oh, hold on. So I'm trying to get 21 right. So each 21, should I focus on the I'm not quite sure what you mean by 21. So, yeah, I mean, if your final exam is 30 questions and if you get 21 out of 30 right, that is a 70%. That's a passing, but each of your instructors may have a slightly different way that they calculate your grade, and depending on what you want your final grade to be, then you might need to get more than a 70% on the final, or you know, maybe you only need a 50% on the final to get the grade that you want. So it just depends on, you know, what grade you currently have and what grade you're shooting for. Um, so yeah, I mean, if you can calculate that ahead of time, then yeah, that's great. So you can kind of, you know, have a goal. But to be fair, everybody's goal should be to get all of them correct. Um, so the way that we find the median is it depends on if we have an even number of terms or an odd number of terms. So if we have an even number of terms, okay, so whenever I have trouble remembering which one to do, I use my fingers. I think we talked about this when we did it for the first time. So I'm just rearranging my ring because the burned side is there. Anyway, if I have 4 numbers and I want the number in the middle, well, that's between the second and third. So how do I determine that? How did I get 2.5? Like the number in the 2.5 position, or technically it's the average. Sorry, you couldn't see that. It's the average of the second and the third numbers. So if there's 4 and I need to get 2.5, if I take 4 and I cut it in half, I'm only getting 2. So what I need to do is I need to cut it in half and then take the average of that number and the one above it. Okay, so those are the steps. You divide by 2, okay, and then you take the average of that and the one above it. Okay, if you have an odd number of terms, so like if I have 5 terms, the number in the middle is the third number. So how do I get 3? Because if I take 5 and I divide it by 2, I'm getting 2.5. I don't want 2.5, I want 3. So I cut it in half and then I go up to the next whole number. Okay, so I divide by 2. So my first step is still the same, but the second step is go up to the next whole number. Okay, all right, so which one do we have here? They told us this is 14 speeds. So that's an even number. So that's one we're going to do. So we're going to take the number of numbers that we have, which is 14, and we're going to divide it by 2. Okay, so that's 7. And we need to take the average of the number in the 7th place and the average of the one above it, or the average of that with the one above it. So the average of the 7th and 8th numbers. Okay. Now I'm looking at these numbers and they are not in order, right? So I can't just say, oh, 1, 2, 3, 4, 5, 6, 7, and then that's 8, because that's not 7 and 8, because these could be jumbled in any order they want. They have to be in ascending order. Okay. So hopefully you guys remember how to do this. You go into Stat and you go into Edit and you pick a list, any list that you want. I'm going to go all the way back down to list 1. If you have numbers in there, you can arrow up to highlight the name. You're going to hit clear and then enter, and it clears the whole list for you. And we're going to put in all of these numbers. Okay, so I've put all the numbers in. Now I want the calculator to sort them. I want them to be sorted in ascending order. So I'm going to go back to Stat, and I'm going to arrow down to sort A, sort ascending. So sort A is sort ascending, sort D is sort descending. So I'm going to say sort A, and I have to tell it which list to sort. Now I put them in list 1. So here I have L1, which is above the 1. So I'm going to hit second and then 1. And I like to close my parentheses, and it says, okay, all done. So now we need to go and look at what it just did. So we go back into stat, back into edit, and it has now put all the numbers in list 1 in order. Now I need to take the average of the 7th and 8th ones. So, which is not too bad if I was just going to like arrow down and count 1, 2, 3, 4, 5, 6, 7. But sometimes you're going to have really long lists and you might lose track. So conveniently, if I start arrowing down, if you look down here, it says L1 and in parentheses, that says 4. I'm on the 4th number in the list. So if I lose track as I'm arrowing down, that's fine because I just need to look at, well, what number in the list am I at? Oh, I'm in list 1. I'm on the 7th number in the list, and that is 196. And I arrow down again to the 8th number in the list, and that is 196.2. So this is the 7th number in the list. This is the 8th number in the list. I'm supposed to take the average of them. So I'm going to do 196 plus 196.2, add them up and divide by 2, and I'm going to get 196.1. So that's how they're getting that. Right. Oh, okay, yeah, so you're trying to get a specific grade. So each instructor weighs the different assignments differently. So you might, I mean, maybe each test is worth, 10% of your grade, and different homework assignments are each worth like 5% or something. So you would have to take a look at your syllabus to see exactly how the grade is calculated to determine like what score specifically do I need on my final in order to leave this class with a particular grade. So I would say let's talk about that afterwards, just so that we can get through all of these, and maybe we can do like a screen share or something, and you can show me your syllabus, and we can take a look at exactly how your grade is calculated, so that we can figure out exactly what you need. Okay, so this next one, the scores of the top 10 finishers in a recent golf tournament are listed below. Find the median score. So again, this is median. So that's the number in the middle. Okay, a TI-30XA calculator. So if you are taking this course online, so I know some of you that come to the reviews are in a face-to-face class, but if you're taking it online, you have a calculator available within within whatever it is, Pearson or whatever, that you have access to, that you can use for things where you have to be doing stuff like that. If that calculator is not showing up for you, then you want to make sure that you reach out to your instructor to ask them where you can find that. If all you have is here, let me find like this. I mean, I know this is not the calculator you have, but so this is a scientific calculator, and this is a graphing calculator. So this has a lot more capability than this does. So this is the one that you need in order to do a bunch of things in this class. So if you don't have a physical one, you should still have access to the electronic version of the calculator through, yeah, I don't know if it's Pearson or, what's another one of those? Well, whichever one you guys have, you should have access to. It's like an emulator, where it's like, hey, this is what a calculator would look like. Type it in as if you're typing onto the calculator, and it shows you what the screen would show if you were using the calculator. Right. Okay, so median. So the number in the middle. So they told us that there are 10 numbers here. So again, that's an even number of numbers. N is 10, right? So we're going to take that and we're going to cut it in half. And then we're going to take the average of that and the next one up, right? We're going to add the fifth and the sixth one up and then divide by 2. Okay, so let's see, are these in order? Yes, they are in order. Okay, so we can just count the fifth and the sixth. 1, 2, 3, 4, 5, and 6. So the fifth one is, oops, it's a 7, is 72. The sixth one is also 72. So what do you think I'm going to get when I add them up together and divide by 2? 72. Right. All right. Okay, so now, maybe not the same set of numbers, but still the top 10 finishers in a recent golf tournament, but now they're asking for the mode. Okay, so remember the mode is the number that occurs, oh shoot, I don't know if I have the right number of R's there, but it occurs most often. Okay, so let's take a look at which numbers occur more than once. So 71 does not occur more than once. 67 occurs twice. 72 occurs 4 times though. So that's the one that occurs the most number of times. So 72 has a frequency of 4. It occurred 4 times. So that's the highest number of repeats. So you might come across a group of numbers that has multiple numbers that occur at that same frequency. So you can have, I think it's called bimodal, where there's 2 modes. But I feel like generally for these, they're just going to give you one that where you just have one mode. All right, number 11, determine whether the approximate shape of the distribution in the histogram is symmetric, uniform, skewed left, skewed right, or none of these. Okay, so let's talk about what each of those mean. So if I have something that looks generally like that, where the tail is on the left, it is skewed left. If I have something that looks generally like that, where the tail is on the right, that is skewed right. If I have something where I can draw, where if I put a mirror in the middle, the 2 sides are reflections of each other, that is symmetric. So I can have a variety of things that are symmetric. There's a bunch of different shapes that would be symmetric. These are just 2 examples of things that are symmetric. And then another situation is where they are all the same all the way across. That is uniform. So uniform also falls under the symmetric category, because if I put a mirror in the middle, the 2 sides are reflections of each other. So uniform is a type of symmetric. So this would be where, each of these is exactly the same height. This is where, it kind of generally goes like that, right? If we're drawing like the rectangles, it can go down and then it goes back up again at about the same rate. So what we have here is generally left skewed because the tail is over on the left side. So I would say if it's an easy question, then go ahead and answer it and move on. So it kind of depends on the way your test is set up. So hopefully your test is the type where you can answer questions, but then you can go back later and change your answers. If that is the way that the test goes, then when you look at a question, If you don't immediately know how to solve it, move on to the next one. Only do that if you're allowed to go back later and go back to questions. I've seen some weird tests where, not in this class, but other classes where once you answer a question, you can never come back to it. So as long as you don't have a test set up like that, as long as it allows you to go back and forth and revisit questions that you've already done, then when you look at a question, if you don't immediately know how to do it, okay, you can go back. Okay, so if you don't immediately know how to do the question, move on to another one, okay? And make a note, on your scratch paper of which ones you haven't answered so that you remember to go back and do them. But if it's an easy question, then just spend the amount of time that you feel is appropriate on it. Don't sit there and, I mean, if you're saying that it's easy, then you're probably not going to be sitting there questioning yourself or second guessing yourself, right? Like when I go through and I write all of this, I'm just doing this because my job is to explain the information to you, not to answer it like I would if I were taking the test, right? Because if I were taking this test, I would say determine whether the approximate shape of the distribution is blah, 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 blah. And I look at this and I immediately say left skewed. And I go and I find it and I move on, right? I'm not sitting there drawing out each of these. I'm just looking at it, thinking to myself, what is the answer? Maybe if I can't come up with, like, maybe I forget, you know, for a second what some of them are called or something. Maybe I look at like my options or something. Like maybe if they hadn't listed them in the question, like determine the approximate shape of the histogram, like if that's all they said. And I was like, oh, I forget, what is that word again? Oh, right, the word is skewed, right? Because they've got the word skewed. Like maybe I do that. But yeah, if you think a question is easy, then only spend as much time on it as you think you need to. Because what you do is you answer the questions that you feel confident about first, and then you go back and you spend extra time on the ones that you didn't know. Because also another thing that you'll probably find is that as you answer questions farther into the test, they'll spark your memory about how you were supposed to do a previous problem. You'll be like, oh, that's right, that's where that menu is, or oh, now I remember where that other thing is, because a question will have something that reminds you of that. Right, approximate the mean of the grouped data and round to the nearest whole number. Okay, so the reason that it's saying to approximate this and not find the exact number is because what we have here is a frequency distribution chart, right? This is telling us that there are 20, I don't know what this is. Let's say this is, I don't know, weights of dogs or dogs that heavy. Let's say we're talking about really big dogs. So or small bears. I don't know, animals. We're going to say animals, the weights of animals. So there were 20 animals that weighed in somewhere between 135 and 139 pounds. Well, we don't know if all 20 of those were 139 pounds, or maybe all 20 of those were 135, or maybe half were down here and half were up here, or maybe they're exactly evenly dispersed through 135 and 139. We don't know. We don't have the original data set, which would have been a whole long list of numbers. All we have is the frequency distribution, so all we can do is approximate the mean, right? Okay, so how do we approximate the mean? Well, we tell the calculator to do it, right? So what we're going to do is in the calculator, we're going to plug in an L1 and an L2. Okay, but we can't plug in 135-139. What we have to plug in for L1 is the midpoints. L2 is their corresponding frequencies. Frequencies, let me be consistent. Okay, so the midpoint of each of these classes is what we're going to put in L1, and the corresponding frequency of the class is what goes in L2. Okay, so we got to find the midpoints, right? So to find the midpoint, we did this earlier, right? We do the lower class limit plus the upper class limit divided by 2. We're taking the average of those class limits, right? So we do 135 plus 139, and then I divide by 2. And if you're not going to do it in 2 distinct steps like this, please do not do that. If you do that, you're going to get the wrong answer, right? Because order of operations, it's going to do that first. So don't do that. If you do want to do it all at once, you have to put it in parentheses, right? And that's the way that we're getting 137. Okay, so the midpoint of my first class is 137. Its corresponding frequency is 20. Okay, so all right, so we have the midpoint of the first class and its corresponding frequency. Now we can either do the same thing for each of the classes after that, or remember our shortcut, we figure out what our class width is and we just add that to our class midpoint time and again and again and again. Okay, so let's do that. To get from the lower class limit to the next lower class limit, we say, what do I have to add to this to get to this? What's 140 minus 135? It's 5, right? What's 140 minus 135? It's 5. So my class width is 5. So I'm going to add my class width to my midpoint to get to the next ones, right? So I'm at 137 and I'm going to add 5. It's going to give me 142. I'm going to add 5 again. And I'm going to add 5 again. And by this point, the computer understands. How many classes do I have? 1, 2, 3, 4, 5. 1, 2, 3, 4. So I just have to hit enter and it does it one last time. So I didn't need this last one down here. And we have our corresponding frequencies. I'm just rewriting it over here just so that they can be a little bit more visible, kind of right next to each other there, right? So this is our L1 and this is our L2, and we're going to have it calculate for us. So we're going to go into the calculator, we're going to go stat, we're going to go edit, L1, I'm going to clear this, so I'm going to arrow up to L1, hit clear and enter, and I'm going to put in the numbers, 137, 142. Wait, hold on, 137, 142, 147, okay, 152, 157. Same thing here, arrow up, clear and enter. Okay, so I put in my midpoints into L1, I put my frequencies into L2. Then we're going to go to stat, and we are going to arrow over to calculate, right? So this is the stuff we were doing in those first couple of chapters. Stat, then calc, one var stats. And we tell it, okay, I had things in L1 and I had their corresponding frequencies in L2. So I need to make sure to tell it L2. So remember, L2 is down here in this sort of greenish color above 2. I mean, your calculator might look different, but that's the color it is on mine. So the X bar is our mean, right? So if we round this number, so you guys can't see that. Ugh, you can't see the whole thing here. If we round that number to the nearest whole number, right? So that's right here. We look to the number to the right to see if this is 5 or more. If it is, this goes up 1. If it's not, this stays the same. It is 5 or more, so this goes up to 147. So that's how they're getting 147. Okay. All right, number 13, the grade point averages for 10 students are listed below. Find the range. Okay, so the range is how far it goes in each direction. I'm going to go through a lot of lead today. The max minus the min, right? Your highest value minus your lowest value. So our highest value is, these are not in order. Okay, it looks like our highest value is 4.0. And it looks like our lowest value is 0.8. So in the calculator, if I do 4.0 minus 0.8, I will be left with 3.2 because the range is max minus min. All right, find the sample standard deviation, round to the nearest tenth. So reminder about uh, symbols. So we have sample statistics, and we have population parameters, right? And we have things like mean and standard deviation and things like proportion, right? So for the sample mean, it's an X with a bar over it. And we just pronounce that X bar. The population mean is this symbol, which looks kind of like a fancy U, like a little cursive U, and it's pronounced mu. It's the Greek letter mu. For sample standard deviation, it's just the letter S, just S. But for population, it's this like O with a little tail at the top, which is the Greek letter sigma. And then for proportions, it's just the letter P. And oh, nope, I said that backwards. The sample is the P hat. Right, that's how we pronounce that. And then population proportion is the P. Right, so hopefully you guys are familiar with those. You got to make sure that you have those straight. Okay, so I say all that because they want us to find the sample standard deviation. Because when you plug in numbers to the calculator, it doesn't know if you just gave it sample information or population information, right? Because for all it knows, maybe your population is only, 10 things, 10 numbers. It doesn't know. You have to tell it, right? Well, not you have to tell it, but you have to interpret from it what you have. So what you're going to do is you're going to plug these in, and you're going to do the same thing we did before, where you're going to have it calculate one var stats. Okay, so we go to stat, then we go to edit, we go to whichever list we want. I'm just going to keep using list 1 and list 2, so I'm going to keep clearing it and adding in the numbers that we have. Okay, then I go back to stat, I go over to calc, and I hit enter on one var stats. Now, I put these numbers in list 1, but I did not have a corresponding frequency list. So I need to make sure that I clear that and say, no, there's no frequency list. It's just, this is the raw data. Okay. And then calculate. So it gives us a bunch of things, right? So it gives us X bar, that's our sample mean, okay? It also gives us this S sub X and the sigma sub X. The S sub X, oh, sorry, from my view where I'm pointing is not where you guys see that I'm pointing. Yeah, so this number, this S sub X is your sample standard deviation. And this number, sigma sub X, that's your population standard deviation. And you'll notice that they are slightly different because there is a slightly different formula when you calculate sample standard deviation versus population standard deviation. Now, calculating the mean, you'll notice that they didn't give you a mu because the formula to calculate mean is the same whether it's population or sample, but that is not true for standard deviation. It matters if it's sample or population. Slightly different formula is going to give you a slightly different number. So they asked for the sample standard deviation, which is, if we round to 1 decimal, is 4.8. Okay, 4.750939757, right? This number right here, we round to 1 decimal, it's 4.8. All right, for the following data set, approximate the sample standard deviation to the nearest tenth using the grouped data formulas. Okay, so again, we can plug this into the calculator, but we need to have a list 1 and a list 2. List 1 is going to be the midpoints of those classes, right? Because we have to tell the calculator that we want halfway between here 9 times, and halfway between here 22 times, and halfway between here 28 times. So we're going to do the exact same thing that we did in the other problem. I think it was 2 or 3 problems ago. We're going to start by finding the midpoint of the first class. So I add them together and divide by 2. So the midpoint, label this midpoint, the midpoint of the first class is 1.5. I can either continue doing that add them up, divide by 2, add them up, divide by 2, add them up, divide by 2 for each class, or I can take the shortcut, which is to first calculate my class width. Yes, I need to calculate that, but once I have it, I just add it to each one. Okay, so the class width is how do I get from here to here, right? The lower class limit to the next lower class limit. Or you could do the upper class limit to the next upper class limit, whichever one you want. So what do I have to add to 1 to get to 3? If it's a complicated number, you can do the math over on the side. I had to add 2. So I have to do plus 2 to get to each one, right? So I'm going to do plus 2 to get to my next midpoint. So again, I can just plug that into the calculator, right? 1.5 plus 2, and then plus 2, and then plus 2, and the calculator understands the pattern, so I just have to hit enter, and it does the last one for me. Okay, so midpoints are your L1, frequencies are your L2. So we're going to take those and we're going to plug them into the calculator. We're going to go stat, edit, L1 is my midpoints, and L2, I'm going to clear it, and that's my frequencies. Then we're going to say stat again, calculate 1 var stats. We need to make sure that it's looking at the right list or lists. We have midpoint and frequency. So this is list 1 and list 2, L1, and then I have to tell it L2. Again, L2 is down here, right? So I go second 2, and then I tell it to calculate. And it gives me a bunch of information. And what were they asking for again? They wanted the sample standard deviation. So the sample standard deviation is the S, not the sigma. So that's 2.1 if I go to 1 decimal place. Okay, I'm going to take a quick drink of water, read through that question, see if you can answer it before I do. Or like in your head, you know. Okay, that didn't take nearly as long as I thought. Let's read it together. Explain the relationship between the variance and standard deviation. Can either of these measures be negative? All right, so the variance is the standard deviation squared, right? The way that we get standard deviation is we take the square root of the variance, right? We take the square root of the variance. And I don't know if you remember, you know, back when you were first learning this in the first few chapters, we talked about how it sounds a little confusing because, like, why would we start with the thing that is being squared and then work backwards and you know, take the square root of it? Why wouldn't we start with this and then square it to get that? Well, it's because if we do, oh, hold on. Okay. It's because if we do this by hand, which you guys aren't doing these by hand. I mean, you were taught that there's a formula, but you're never going to be expected to do the formulas by hand. Then what you end up with first is the variance. And so that's why it's written that way, because you end up coming up with the variance first, and then you have to take the square root of it in order to get your standard deviation. Okay. Okay, so the standard deviation is the positive square root of the variance. They did specify the, so really we just started talking about this question, that's all. The fact that the variance is the square of the standard deviation. And to get the standard deviation, you take the square root of the variance. So the standard deviation and the variance can never be negative, and squared deviations can never be negative. So first of all, it's saying they can't be negative. Okay, whichever way you think about it, they can't be negative, because if I have, let's say I'm talking about the standard deviation. Okay, let's say that I have a standard deviation. If I take, let's say it was a negative. I mean, it's not, it's never going to be, but if it was a negative number, if I have a negative number and I square it, right? So I multiply it by itself a total of 2 times, a negative times a negative is a positive. I'm only able to get a positive, even if I did have a negative. But I never have a negative, because both of these have to be positive. And if I start with this, and I'm saying, okay, I want to get to this, whoops, not A, then the rule is that I don't just take the square root of it. Oh my gosh, why do I keep writing A instead of sigma? I don't know. I don't just take the square root of it, but I take the positive square root of it. So I'm not going to get into the whole like positive and negative square root thing. So there, for this question, there's not really anything to like do. So you're not like doing anything faster. You're just reading the question and saying which of these answers make sense. So kind of as like a general test taking rule, you read the question, you think to yourself what you think the answer is that you should be looking for, and then you read the options one by one and narrow them down as you go, right? So there's no you're not writing any of this down. I'm just doing this to show you. So there's nothing to like do. You would go through and you would say, the variance is the negative square root of the, nope, that's right out, because I know it can't be negative. The standard deviation is the negative, nope, that's out, it's not negative. The standard deviation is the positive square root of the variance. Okay, that sentence is true. The standard deviation and variance can never be negative. Yeah, that's true. Squared deviations can never be negative. Yeah, all that's true. And you could just stop right there. Now, if you have time and you want to be super thorough, you could read option D to see if maybe you misread and maybe D is actually the answer. But you read D and it says the variance is the positive square root of the standard deviation. No, that's not right. That's the opposite. It's not that the variance is the root of it, of the standard deviation. It's that the standard deviation is the root of the variance. So that's out too, right? So for some of these questions, you have to write stuff down and you have to plug stuff into the calculator. But for many of these questions, you're just reading it and selecting the correct answer without having to write anything down or do anything in the calculator. The test scores of 15 students are listed below. Identify potential outliers, if any, for the given data. Okay, so these numbers do look to be in order. Okay, so you would look at these and you would say, all right, well, I see we got some people with A's and B's and C's and D's, and we're even getting down into F's, right? So it wants to know about potential outliers. So what we're looking for is like if we were to maybe plot these on a number line, which are super far away from the other numbers, okay? So like this top one here, that's 9 away from here. Well, that's not a super far distance, especially considering that, you know, they're like from here to here, you know, is 8, right? So it's not super far away, okay? But we get down into these low numbers and we say, okay, I mean, 39 is the lowest, but it's only, you know, 9 away from here, but this one is really only 3 away from here. So we don't want to include 48 because it's actually pretty close to 51, right? So, all right, I'm trying to think how we would determine that it's this one and not this one. Like what's kind of like a just sort of like a rule, hard and fast rule I can give you guys as to how you would know that it's 39 and not 39 and 99. Um, hmm. So, yeah, I mean, hmm. So yeah, this is funny. I don't remember running into this issue last time I did this, but yeah, um, you know, we would say, well, we don't need to include 48 because it's really only 3 away from the next number up. But from 39 to 48 is a jump of 9, but also from 90 to 99 is a jump of 9. So why is it that this one is an outlier and that one isn't an outlier? So I'm wondering, because I don't think they want you guys to, uh, oh, you know what? Because these aren't just random numbers. These are test scores, right? Test scores of students. So we're talking about like, did you pass with an A? Did you do really well? Or did you fail miserably? Right? Right. So yeah, these students failed, right? But this one failed much more significantly than that one did, right? So this is you got an A. This is somebody who, you know, they got an A and they got almost 100, but it's not super crazy that they got a 99. But this one, they're all the way down at the bottom. Because if you look at like most of the scores, and you know, it's funny because I was talking about like a number line, right? So here's 0, here's 100, right? So if I have like a 99 and like a 90 and an 87 and an 82 and a 79, 77, 74, yeah, 73, 71, 68, 66, 65, 51, 48, 39, right? So these are all kind of grouped together at the top. Yeah, there's like some spacing in between them, but this one is separate down here. Like, yeah, there's some space between this and this, but these are all grouped together at the top, and this is all on its own way down here. Okay. All right. Okay, a student's grade on the fundamentals of engineering exam has a z-score of -0.5. Make an observation about the student's grade. All right, so got to remember what z-scores are. Z-scores are how many standard deviations you are away from the mean, right? Here's the mean in the middle, and I'll go like 3 out in each direction. So we have a z-score of 1, positive 1, that's to the right. 2, or 3. A z-score of 1 means that you took the mean and you added 1 standard deviation. A z-score of 2 means that you took the mean and you went to the right, or you added 2 standard deviations. A z-score of 3 means you took the mean and you added 3 standard deviations. Right? When you go to the right, you are adding. You're getting positive z-scores. If you go to the left, you are getting negative z-scores. This is a z-score of -1. This is a z-score of -2. And this is a z-score of -3. So this is where you take the mean and you subtract 1 standard deviation. A z-score of -2 is you take the mean and you subtract 2 standard deviations. A z-score of -3 is where you take the mean and you subtract 3 standard deviations, right? So you're starting in the mean, at the mean in the middle, and then you're going a certain number of standard deviations either to the right, which means you have a positive z-score, or you're subtracting it, which means you're going to the left, so you have a negative z-score. Okay, so make an observation about the student's grade. The student's grade on the exam was below average because it has a negative z-score. It is below the mean, which is the average, right? Mean means average. Okay. A six-sided die is rolled. Find the probability of rolling a 7. All right, so if we remember what our sort of ranges are for what probabilities can be, they can be anywhere from 0 to 1, right? 1 is if it is certain, if it is inevitable, right? So if I say, if I look outside and I see that it's raining, I can say the probability that it is going to rain today is 1 because it's currently raining, right? I'm certain that it's raining. 0 would be something that could never happen, right? That is impossible, right? So if I'm at home and it doesn't rain the entire day at my house, the next day, I would say the probability that it rained at my house yesterday is 0 because it never rained. It's not possible. And then we have all the decimals in between, right? So this is saying that we start out with a 6-sided die. And they want to find the probability that we roll a 7. Well, there is no 7 on a 6-sided die. So I can't roll a 7. It's impossible to roll a 7. So because it's impossible, it can never happen, the probability is 0. Okay. Okay, if one card is drawn from a standard deck of 52 playing cards, what is the probability of drawing an ace? So you can put the number of aces over the total number of cards, right? So you guys do have to make sure that you have a general understanding of how a deck of cards is separated out, that you have 4 suits, 2 of them are red, 2 of them are black, that you have Jack, King, Queen, and Ace are the face cards. No, I'm sorry, Jack, King, and Queen are the face cards. Ace is not a face card. And you have to know, like, you know, what is it? Spades and I forget. Let me pull out the book and we'll show which ones are red and which ones are black. Where's my book? You know what? We won't do that for this one because this one's not talking about the colors, but half the deck is red, half the deck is black. So the number, and there's one of each type of card in every suit. So there are 4 aces in the deck because there's an ace of every suit. So there's 4 aces, and they're reminding you that there's 52 cards in a deck. So you're going to do 4 out of 52. Now, if this was a fill in the blank, you would want to just plug that into your calculator and get the corresponding decimal. But this is being written as a fraction. So either you can reduce this manually, or you can have your calculator reduce it for you if you're feeling uncomfortable reducing it. So if I have 4 out of 52, I can go to my calculator, I can go to math, right? And then if I arrow over to number, or no, I'm sorry. It's not even a number. It's the very first option right there under math. It's right there. This says arrow fraction. We're going to hit enter because we want it to take the fraction, I'm sorry, the answer that we had and turn it into a fraction, the most reduced form of that fraction. So that's going to be 1 over 13. Okay. Now, if you wanted to do that by hand, it might take you a couple steps, right? Because maybe you don't realize that 4 goes into 52, so maybe you start reducing by 2. You see that these are both even, so you say, oh, I'm going to reduce both of these by 2. So I'm going to divide them both by 2, right? 4 divided by 2 is 2. 52 divided by 2 is 26. And then you realize, oh, these are still even. I can divide again, right? I can divide them both by 2 again. 2 divided by 2 is 1. 26 divided by 2 is 13. So feel free to do it by hand, but it's going to be faster if you just let the calculator do it for you. And also, you're less likely to run into like an error, right? Like you might make a mistake if you're writing all this out. Now, if you guys were doing homework problems, I would say absolutely do it by hand, right? You want to keep your skills sharp. You want to make sure that you know how to do this sort of reducing. But when it comes to a test, you're not practicing on a test. It's time to perform, right? No more practicing, you are performing. So you're saying, all right, I'm just going to plug this into the calculator so that I can be 100% sure that I get the right answer. Okay. All right. Okay, if one card is drawn from a standard deck of 52 playing cards, what is the probability of drawing a heart? So again, you have to remember that you guys have, you've got hearts, you've got clubs, you've got diamonds, and you've got spades. I forget which colors are which. But those are your 4 suits. And altogether you have 52 cards. So if you don't have memorized that there's 13 in each suit, you can just say, okay, well, 52 cards divided by 4 suits. Oh, that's right. There's 13 cards of each suit. Okay. Because what we're going to do is we're going to say the number of hearts over the total number of cards. Just a second for a drink. So number of hearts is 13, and the total number of cards is the whole deck is 52. So either we say 13 over 52, or if we look over here, we can see, oh, that's right. It's in the simplified form. There's 1/4 of the deck is hearts, right? The deck is divided into 4 suits, and only one of those, that's a spade, only one out of the 4 suits are hearts. So you can think of it either way. Or you could take this, plug it into your calculator, and have it reduced just like we did on the last one. All right, let me get out my highlighters here, because these are these type of problems. Let's see, green. Let's do green and pink. It's very easy to tell apart. Okay, a group of students were asked if they carry a credit card. The responses are listed in the table. We got freshman, sophomore. We got people who have cards, people who don't have cards. If a student is selected at random, find the probability that he or she owns a credit card given that the student is a sophomore. Okay, so when they say given is your new sample space. Right? So in all these problems that we've done so far, the denominator is our sample space, right? The number of things we have to choose from, our n, right, is the total number of things we have. Well, when they say given, they've said forget about everything else. You're only looking at these people. So our denominator is going to only be the total number of sophomores, right? So I am only allowed to look at sophomores, only sophomores. So how many sophomores did we have? You know what? Let's deal with that in just a minute. Let's finish saying what my numerator is. They want find the probability that somebody owns a credit card given that they're a sophomore. So somebody who owns a credit card who is a sophomore, the number of credit card. Oh, I'm just trying to fit this in here. Just ignore this for a minute. The number of credit card owners who are sophomores. So your given creates your new denominator, right? So given that they're a sophomore, so sophomores is all I'm allowed to look at. I'm only allowed to look at this row. So when they say the probability that they own a credit card, I can only look at where that overlaps with the only part that I'm allowed to look at. I'm only allowed to look at the row of sophomores. So how many people who are sophomores own a credit card? This many right here, just 29. Wow, a lot of breaking things here. Okay, the denominator is your new sample space, you're given 40, right? So Mohammed, I just kind of re-said the question from the beginning when you hopped in. Right, I said that the given is your new sample space. That's your denominator. So this is what we're going to plug into the calculator. So what goes in the numerator is where those two things overlap. What goes in the denominator is your new sample space. There's a total of 40 sophomores. Right, the total number of sophomores goes there. So 29 out of 40. All right, 23, similar type problem. We have, again, the credit cards, freshman and sophomore. So now the question is, if somebody selected at random, what's the probability that they're a sophomore given that they own a credit card? The given is the new sample space, right? They own a credit card. That's the only stuff I can look at. I'm only allowed to look at that. So just to clarify, I could go into a little bit more detail here. Instead of sophomores, I could put like total number of sophomores. I could word it that way. Okay, because that's what I'm going to say here. Total number of students who own a credit card, right? Because that is the new sample space. That's my new denominator. Okay. And what is the numerator? Find the probability that they are a sophomore. So where did sophomore and credit card carrier overlap? that's what goes in my numerator. So the number of sophomores who own a credit card. So where sophomore and credit cards overlap goes in the numerator, that's 10. And what goes in the denominator is my sample space, which is only people who have a credit card. Right? So only people who have a credit card. So that's 35 people. Zoom out a little bit more. So if I take 10 out of 35, that's how they're getting 0.286 if you round to 3 decimals. Okay. Same type of thing, just slightly different question. Find the probability that they're a sophomore and they own a credit card. All right, so they said and. They didn't say given, they said and. Okay, so that means that we are looking at the and means intersection. Section. Okay, so the numerator is going to be the intersection of those things, of the two things that they're asking about. The denominator is just the total, like all total. They haven't asked us to narrow it down into, just looking at this group or just looking at that group. We have to look at the total number of people in this study for the denominator. The numerator is the intersection of the two things that they're asking about. Okay, so what are the two things they're asking about? That they're a sophomore. Okay, so I'm going to highlight sophomore. And that they own a credit card. So here's sophomore and they own a credit card. Okay, so what's the intersection of those two things? It's 13. And how many people were in the study total? Well, that's right here. There were 100 people total. So if I take that and I plug it into the calculator, I'm going to get 0.130. Keep in mind, when you plug this into the calculator, it's just going to give you 0.13. Technically, there's an infinite number of zeros behind that. You can stick how many ever zeros you want there. They're specifically going to 3 decimals, so they've written 1 0 on the end of it, just so that it goes to 3 decimals. But 0.13 is exactly the same as 0.130. All right. Okay, 2 cards are selected from a standard deck of 52 playing cards. The first card is not replaced before the second card is selected. Find the probability of selecting a spade and then selecting a diamond. Okay, so what we're going to do is we're going to multiply the two probabilities together. The first thing that I fill in here is going to be the first pull, and the second thing I fill in here is going to be the second pull. All right, so they said find the probability of selecting a spade and then selecting a diamond. Okay, so this is going to be selecting a spade. So the denominator is the total number of cards in the deck, which is 52, and the numerator is the number of spades in the deck. Well, that's a quarter of the deck, so that's 13, because there's 13 spades in a deck. Okay, now I've taken that card out, and I have not put it back, right? I'm not replacing it. So when I go to do the second pull, I no longer have 52 cards to pull from. I only have 51 cards, right? The first pull is affecting my second pull. I only have 51 to choose from. And then they want to know if the second pull is a diamond. Now, I pulled a spade here, so pulling a spade out doesn't affect how many diamonds are still sitting in the deck. I still have 13 diamonds. I didn't pull out a diamond, I pulled out a spade. So I do have a 13 in the numerator. but the denominator changed to 51. And again, if you're doing this in the calculator, please just use parentheses to make sure that you don't have any issues with order of operations. Right? And then make sure that you're rounding to the number of decimals that they're asking you for. So that's how they're getting 0.064. Okay. All right, according to a study, 74% of K through 12 schools or districts in a country use digital content such as ebooks, audiobooks, and digital textbooks. Like they just use them in general. But of these 74%, 6 out of 20 specifically use the digital content as part of their curriculum. Find the probability that a randomly selected school or district uses digital content and uses it as part of their curriculum. So we are going to multiply these two probabilities together. Okay, we're going to multiply that 0.74 times the 6 out of 20. Right, because you can have probabilities as decimals or you can have them as fractions. But we would multiply both of them together to find the probability that a randomly selected one does both, right? The and is what tells us to multiply. So we go 0.74 times 6 out of 20. And that's how we're getting 0.222. Okay. All right. The table lists the smoking habits of a group of college students. Okay. If a student is chosen at random, find the probability of getting someone who is a man or a woman and round your answer to 3 decimal places. We're going to do this the easy way and we're going to do it the hard way. So the hard way is where we say, they said or, okay? So I'm going to do the probability that someone is a man or that someone has reported their gender as a man plus the probability that someone has reported their gender as a woman. And when you have or, you have to add them together and you have to subtract where they overlap. Right? That's the full formula, is when you have or, this or that, you add them up and then you subtract where they overlap. Okay? All right, so the probability that that somebody was a man, so if we're talking about men, we're looking at men here, right? So out of all total, all 406, how many of them were men? 192 of them reported as being male. Okay, and then for women, out of the total of 406, how many of them reported that they were women? 214 of them. And then we would subtract, out of the total of 406, how many reported that they were both a man and a woman? None. That was not something that was done in the study. There was no overlap. Okay, so if we add these up, add these and subtract 0, we get 406 out of 406, which is just 1. So also, let me just clarify. Or is the addition rule, right? The probability of A or B is the probability of A plus the probability of B minus the probability of A and B, right? Where A and B intersect, right? That's the rule that we used there. Okay, so if you just use the rule, you're going to get 1. And then you kick yourself because you realize, oh, They only gave two options. I can only select man or woman, and they're asking, what's the probability of somebody who selected this or that? Well, they had to select something, so that's everybody. So there's 100% chance that I'm going to get somebody who made that selection. There was no choose not to answer option, right? It was one or the other. So you don't actually have to do this math when you have a question like this, right? It's just, what's the probability of getting somebody in the first group or somebody in the second group when I only gave people the option of choosing one out of the two groups? It's 100%, right? I'm pretty sure there was a question like this on the test review for this chapter as well. So hopefully that looks familiar to you guys. All right. The distribution of master's degrees conferred by a university is listed in the table. Assume that a student majors in only one subject, okay? So we've got math, English, engineering, business, and education. What is the probability that a randomly selected student with a master's degree majored in English or mathematics? Okay. So this is or, right? The probability of English or math, I shouldn't use those letters because that could also be engineering. Of English or math is, so or, this is the addition rule, the probability that they're English degree plus the probability that they were a math degree minus the probability that they got both an English and a math degree. And what can we say about this one right off the bat? It's 0 because they told us they only majored in one subject. There is no overlap, okay? Now you'll notice I didn't put a denominator here because I don't know what the denominator is yet, right? They didn't tell me how many students total got master's degrees. So I'm going to have to add all those up, right? I'm going to add up all of those numbers to get that the sum of the frequencies is, let's find out what it is. $9.15. Okay, sum of the frequencies is 9.15. So the total number of students that were asked or that got master's degrees at that university was 915. And now we're going to find these probabilities. So these denominators are also 915, right? That's how many total students got masters. How many of them got their masters in English? 206. How many of them got their masters in mathematics? 225. So we're going to add these up and subtract 0. I'm not going to actually plug that in because that's not going to actually change any of the math, right? Okay, and take that and I round it to 3 decimal places. That's how they get that answer. Okay, the Environmental Protection Agency must visit 9 factories for complaints of air pollution. In how many different ways can a representative visit 5 of these to investigate this week? Okay, so when we're choosing a certain number of things, either the order matters or the order doesn't matter. If the order matters, it's a permutation. If the order doesn't matter, it's a combination, which is why I get so mad that they call those locks that you would like have on like your bike lock or in your locker in high school. They should not be called combination locks because they aren't combination locks. They're permutation locks because the order absolutely matters. Very upsetting. Okay, so if the order matters, it's a permutation. If the order doesn't matter, it's a combination, right? Permutation is the P, NPR. The combination is a C, NCR, where N is the total number of things we have to choose from, and R is how many of them we're choosing, right? So there are 9 factories that are available, and we're going to choose 5 of them. So there's 9 available. We're going to choose 5, and am I putting a P or a C here? Well, that depends. Does the order matter or does it not matter? Well, they asked how many different ways can they visit them. That's telling me that the order matters. So that's a permutation, right? Like who gets visited first? Like they have to schedule these things, right? So like who's getting visited on what day? That's something that has to be put into a calendar. It matters. All right, so there is a formula for doing that. You are expected to know that that formula exists. You are not expected to use that formula and do it by hand. Nobody wants you to do this by hand. That's a waste of time. They want you to know that there's a formula that allows you to do it by hand. But when it comes to doing this on the test, they're expecting that you're using the calculator, right? Okay, so where do we do this? This is we go to math. Okay, and then we're going to go over to probability. So I'm just going to go to the left twice to get there faster. And I'm going to arrow down to number 2 because that's permutation, or I'm just going to select the number 2. And I'm going to fill in the boxes. There were 9 things to choose from. I'm choosing 5 of them, and the order matters. So I have 15,120 different ways that I could do that. Right? Order matters as a permutation. Order doesn't matter as a combination. Okay, 30. There are 14 finalists in a singing competition. The top 6 singers receive prizes. How many ways can the singers finish first through 6th? So it matters if you are first or if you are 6th, right? If you're in a competition, it matters what place you land in. So that's a permutation, right? Okay, there are 14 finalists. That's how many people we have to choose from, and we are choosing 6 of them. So this is 14P6, or 14 choose 6, where the order matters. So again, we're going to go, oh, also, if I wanted to, I could type the 14 in before I go to the menu where this is. So like if I type in 14 and then I go math, probability, NPR, it's like, oh, you wanted to take that 14 and have it be part of this? Okay, and it just automatically puts that in. So you can either put this first number in first, or you can put this in and then put that in. And that's how they get 2,162,160. Right? Lots of different ways to do that. Okay, number 31. The random variable x represents the number of boys in a family of 3 children. Assuming that boys and girls are equally likely, find the mean and the standard deviation for the random variable x. So for these, all you're doing is you're plugging in L1 and L2, right? That's all you're doing. And then having it calculate. So you go stat, edit. I'm going to put this in L1 and L2, 0, 1, 2, 3. And for L2, we have okay. So also, just to clarify, what this is saying here is that the probability of having 0 boys in a family of 3 children is 0.125. The probability of having 1 boy in a family of 3 children is 0.375. The probability of having 2 boys in a family of 3 is 0.375, and the probability of having all 3 boys in a family of 3, or I'm sorry, of 3 children is 0.125. That's what this means, okay? So each of the possibilities and its corresponding probability, but you treat it much like you do a frequency distribution, right? Where this is your L1 and this is your L2. Plug that in and then you have it calculate. So we go stat and then arrow over to calculate, one var stats, and we do give it L1 and L2 and tell it to calculate. So you want to make sure that you're just looking at the right symbols, right? So that's how they're getting these numbers. And when you give it probabilities over here, you'll notice that it never gives you a sample standard deviation. It's only ever going to give you the population standard deviation. So you'll probably notice that. Okay. All right, we are at question number 32 out of 60. So we're 2 hours in. I'm going to go ahead and take a pause here. I'm going to get some more water. We're going to take a quick bathroom break. I'm going to put that in the chat here so everybody knows. We're going to take a quick break and then we'll be right back, okay? I'm talking like 5 minutes, okay? We're taking a quick break. We'll be back in a few minutes. Stand by. Okay, be back ASAP. Okay, thank you for your patience. We are back. Let's dive into the rest of the second half here. Okay, move. Gotta move the keyboard out of the way here. I think I've said before, this office is not the best to do this in. Okay, so 32. Determine the probability distribution's missing value. The probability that a tutor will see 0, 1, 2, 3, or 4 students. Okay, so with a probability distribution, all of the probabilities have to add up to 1, right? They all have to add up to 1. So you're going to do 1 minus what's already sitting there to get the missing value. So that's 0.55 plus 0.13 plus 0.2. 1 plus 0.02. And you can do that all at once, or you can do it in 2 separate chunks. Where did I put my calculator? So if I do it in 2 separate chunks, the rest of it adds up to 0.91. So if I subtract that from 1, that's how I'm getting 9%, or 0.09. Right? Okay. Okay, the probability that an individual is left-handed is 0.170. In a class of 36 students, what's the probability of finding 5 left-handers? Okay, so we got to remember what tools to use here, right? We're going to use binom PDF because that allows us to find the exact value of X, right? So to get to that, we do, what is it? We do second var, yeah, so let me write this down. We do second vars, right? So second vars, and then we go, I think it's farther towards the bottom, yeah. So we go all the way down to option A, which is binom PDF, okay? And then we have to tell it the number of trials, the probability of success in a trial, and the exact number of successes that we are looking for. I think I said this before, if you have a fancy calculator, it's going to prompt you to plug these types of things in. If you have an older calculator, you can still do this, but you have to know that you have to put them in the order NPX. Okay. So, okay, the number of trials. Well, what is the number of trials here? Well, we have 36 students. That's our N. The P, they told us at the beginning of being left-handed, is 0.17, or specifically 170. And they want to find the probability of finding exactly 5. So that is our X, is 5. So N is 36, P is 0.17, X is 5. Right? So out of 36 people, if the probability of a left-handed person, of being left-handed is 0.17, in that group of 36 people, what's the probability that we get exactly 5 left-handed people? And when we take that and round it to 3 decimals, that's how we're getting 0.166. Okay. I think I've said this before, but a good way to go through these videos, if you're watching the recording, is to read through the question. If you can't see it because it's too small, wait for me to read it out loud. Then pause the video, try and do the problem yourself, and then unpause it and watch me do it and make sure we get the same thing. Right? Okay, 34. According to police sources, a car with a certain protection system will be recovered 85% of the time. Find the probability that 5 of 8 stolen cars will be recovered, and then round to the nearest 1,000. So again, this is binome PDF. Our N value is out of the 8 cars. Okay, our P is the probability it'll be recovered, which is 0.85. And our X, how many exactly do we want to know? The probability of exactly that many being recovered, that's 5. So again, we go. So you can either do, if you have these questions back to back, you can go back into the menu, second vars, go all the way down to A, or you can arrow up, highlight that and hit enter. It'll copy and paste it, and then you can go in and you can change the numbers in here. So we have 8, comma 0.85, comma 5, and I need to get rid of that second 5, so I'm going to hit delete to get rid of that. All right, and again, we round to 3 decimals. That's how we get 0.084. Okay, 35. Find the area of the indicated region under the standard normal curve. All right, so you can either look this up in the chart, in the book, or they'll have the chart available for you, I would imagine, for this problem. And you'd look up a z-score of negative 1.3. That's going to tell you the area to the left of it. You would take that number and subtract it from 1 to get the area to the right. Another way you could do that is you could say, well, if I just sorry, you can't see what I did there with my fingers. If I just flipped this around, and if I just had a z-score of positive 1.3, then this area, the area to the left of positive 1.3, is exactly the same as the area to the right of negative 1.3. So you could look up a positive 1.3 in the back of the book or in the chart, and it'll tell you the area. Or you can do it in your calculator. So let's do it in the calculator. So this is going to be normal CDF. So this is going to be, you're going to go second vars. All right, so I'm going to go second vars, and it's going to be the second option, number 2, normal CDF. Okay, so you're going to give it your lower bound of the shaded region, then the upper bound of the shaded region, then your mean, which you want to leave at 0, and your standard deviation, which you want to leave at 1. Okay. So our lower bound, it's defaulted to negative infinity, or as close to that as we can get when we're plugging in kind of just on the fly here, negative 1 times 10 to the 99th. Well, that's not our lower bound. Our lower bound is negative 1.3. Now, I could do it this way. I could say lower bound is negative infinity, upper bound is 1.3, but let's just stick with what they actually gave us. We don't want to make this more complicated than it needs to be. All right, my lower bound is negative 1.3. My upper bound is infinity, but I can't write infinity in the calculator, so I'm going to say 1 times 10 to the 99th. I'm going to leave my mean and my standard deviation as 0 and 1 because they said this is a standard normal curve. And that's how we're getting 0.9032 when we round to 4 decimals. Okay. Okay, 36. Provide an appropriate response. Use the standard normal table to find the probability. We're just going to use the calculator. The lengths of pregnancies of humans are normally distributed with a mean of 268 days and a standard deviation of 15 days. Find the probability of a pregnancy lasting less than 250 days. Okay, so let's draw a picture of what that looks like. Here's our mean. Standard deviation of 15. Okay. Lasting less than 250. So 250 is to the left of 268, right? This X value of 250 is to the left of 268. Right, you cannot see that, can you? They want to find the probability that a pregnancy lasts less than that, so to the left of that. So I'm going to shade to the left of this X value of 250. Okay, so the fastest way to do this is going to be that same normal CDF, right, that's second VARS, normal CDF. The lower bound is -1 times 10 to the 99th. The upper bound is this X value of 250. Now, because we put in an X value, we need to make sure that we're putting in the actual mean and the actual standard deviation, right? So if you leave your mean and standard deviation as 0 and 1, then you need to be putting in z-scores here, not X values. Right? If you're using an X value, you need to use the actual mean and standard deviation. If you're just dealing with a z-score, then you leave your mean and standard deviation as 0 and 1. Okay. All right. So move this over here. Our mean is 268, and our standard deviation is 15. Okay. So we're going to go second VARS, number 2, normal CDF. Our lower limit is -1 times 10 to the 99th. Our upper limit is 250. Our mean is 268, and our standard deviation is 15. Okay, and that's how we're getting that the probability of a pregnancy lasting less than 250 days is only about 11.5%. Provide an appropriate response, use the standard normal table to find the probability. An airline knows from experience that the distribution of the number of suitcases that get lost each week on a certain route is approximately normal, with a mean of 15.5 and a standard deviation of 3.6. What's the probability that during a given week, the airline will lose less than 20 suitcases? So again, let's draw a picture of what's going on here. We've got a mean of 15.5. They're asking the probability that they're going to lose less than 20. So 20 is over here somewhere to the right of this. And we want the probability that we're going to lose less than 20. So we're going to shade to the left of that. Okay. So again, we're going to do normal CDF. Our lower bound is -infinity. We can't put that in, so instead we do -1 times 10 to the 99th. Our upper bound is the X value of 20, and because we have an X value rather than a Z-score, or its corresponding Z-score, we need to use the actual mean and the actual standard deviation. The mean is 15.5, and the standard deviation is 3.6. And that's how they're getting 0.8944 when rounded to 4 decimal places. Okay. Okay, give me just a second, I'm gonna have another drink. Okay. Use the standard normal table to find the Z-score that corresponds to the 5th percentile. Okay, and then it says click to view page of the table. All right, so what is the 5th percentile? The 5th percentile is the z-score that separates the bottom 5% from the top 95%. Okay, the area here is 5, the area here is 0.95. Okay, so remember how these tables work, where the numbers on the outside are the z's, the numbers on the inside are the area to the left of that z-score, right? So we want to find inside here, where is 0.05? So I'm going to try and zoom in here as best I can. So what I find is that there is no 0.05, but what there is a 0.0495 and a 0.0505. So those are the same distance away from 0.05. So neither one of those is the closest to the number that I'm looking for. So what I have to do is when I look to the left over here, I can get negative 1.6, but when I look up to the top, I have to look in between these two, right? I have to say, what is the number that's in between 0.04 and 0.05? So I have a negative 1.6 and I have a negative 0.045, right? Because that's halfway between 0.04 and 0.05 is 0.45, right? 4.5 is halfway between 4 and 5. You see that? Right? So these are both negative. So that's negative 1.645. Not that you have to actually like write it out like this, but just these are the first two digits. These are going to be the next digits. Okay. So that's how they're getting negative 1.645. Okay. So if we were to do that in the calculator, right, we should be getting the same thing, right? So normal CDF, the lower bound is negative infinity, the upper bound, or I'm sorry, not normal CDF. We're doing it the other way, right? We have the area, we're trying to find the z-score. That's inverse norm, right? So the area is 0.05. We leave this as 0 and 1, and we make sure that that's the area to the left, right? And if we round that to 3 decimal places, we get negative 1.645. Right, so normal CDF is when you give it X's or Z's and it gives you an area. Inverse norm is where you give it an area and it gives you the corresponding X or Z. Right. Okay. All right, use the central limit theorem to find the mean and standard error of the mean of the indicated sampling distribution. Okay, so the two things we're looking for are the mean and the standard error of the mean. Okay, so real quick, reminder, standard error of the mean, that is, we do this, right? That's the standard error of the mean. Okay, the monthly rents for studio apartments in a certain city have a mean, right? They have a mean of 1,030, okay? And they have a standard deviation of 180. Okay, random samples of size 50, right? A whole bunch of random samples, each of which have sample sizes of 50, are drawn from that population. And the mean of each of those samples is determined, right? Round the answer to the nearest hundredth, right? So the standard error of the mean is where you take your standard deviation and you divide it by the square root of the sample size, right? All those samples that were taken. There were a whole bunch of samples taken of that population, each of them size 50. Okay, so 180 over square root of 50. Right, so we're getting 25 point, if we go to 2 decimals, that's 0.46. Right, that is the standard error of the mean. And the mean itself is just the mean, right? The mean that they gave us, the mean of the population mean, and then the standard error of the mean. You have to know this formula. It's another formula you got to memorize, right? There's a lot. Okay. All right, use the central limit theorem to find the mean and standard error of the mean of the indicated sampling distribution. Okay, the amounts of time employees of a telecommunications company have worked for the company are normally distributed with a mean of 5.60 years and a standard deviation of 1.80 years. Okay, random samples of size 13, right? So the sample size is 13 for all of these random samples, are drawn from the population, and the mean of each sample is determined. Okay, so again, the standard error of the mean, the formula for that is your population standard deviation divided by the square root of the size of all of the samples that were taken. Like each sample has to have the same number of items in it, or the same sample size, and all of those samples, a bunch were taken, but they all have to have the same sample size. Okay, so this is 1.80 over the square root of 13. So that gives us, they want us to round to they want us to round to 2 decimal places. So if I take this and I round it to 2 decimal places, it's actually going to round up to 0.50, right? And then the mean is just the 5.6, the standard error of the mean, so sigma sub x bar is 0.50. So don't forget that formula. Okay, 41. In order to set rates, an insurance company is trying to estimate the number of sick days that full-time workers at an auto repair shop take per year. Okay. A previous study indicated the population standard deviation is 2.8 days. Okay, let's go ahead and label that. How large a sample must be selected? Okay, that's what we're finding, right? N is our sample size. How large a sample must be selected? If the company wants to be 95% confident, okay, our confidence level is 95% or 0.95, that the true mean differs from sample mean by no more than 1 day. So they just told us that the error is 1. All right. Okay, so again, we have to have a formula memorized. Like I mentioned earlier in the review, I will be emailing you a PDF that has all the formulas for for this particular chapter. There were several formulas that you needed. I had them on a PDF. I sent them to you previously. I'll send them to you again. So what is that formula? If we have a population standard deviation, then the formula is Z sub C times sigma over E squared. Okay, so what is Z sub C? So if we have a 95% confidence level, what that means is that the area in the middle is 95%. Okay? The area in both of those tails together is the remaining 5%. So the area in each individual tail is half of that, or 2.5%. Okay? The z-score that we're looking for is the one that corresponds to the positive one. Okay? So, so the area to the left of that is the 0.95 plus the 0.025. So the area to the left of this is 0.975. Okay. So if the area to the left is 0.975, we can find the corresponding z-score, right? The corresponding z-score related to our confidence level, by using the inverse norm, right? Inverse norm. So we do second vars inverse norm. Okay, second vars, we go down to inverse norm. And you know what I just remembered? That this is the fancy calculator. So if you have the fancy calculator, you can say, oh, well, it's an area of 0.95 in the center. And you get this positive one, the z sub c is 1.96 if we go to 2 decimals. Now, if you don't have the fancy one, then you do say that the area is 0.975 because it can only give you the area to the left. Or, like, if you wanted to do this by hand, like if it's going to provide you with the chart, you're going to look up an area of 0.975 inside the body of the chart, right? So inside the middle of the chart, and then you look to the top and to the side to see what the corresponding z-score is, right? So whichever way you do it, you're still getting 1.96 when you go to 2 decimals. All right, so that's my z-score, 1.96 times, they told me my population standard deviation was 2.8. They told me my margin of error was 1, and I need to square that. Okay, so anything divided by 1 is itself, so I'm not going to even plug that part into the calculator. I'm just going to do 1.96 times 2.8, okay, and then I'm going to square it. Now, this gives me 30.118144, right? However, this isn't just a random number. This represents n, which is a sample size, which is the number of people we need in the study to be sure that our margin of error is only 1 at a confidence level of 95%. So I can't use my normal rounding rules with this and say, oh, I'm going to take that 30 and turn it in, or 30.118144 and turn it into a 30, because this is the bare minimum threshold that I have to reach to be sure that my margin of error is 1 at a confidence level of 95%. I have to reach this 30.118144. Well, we can't take parts of people, right? So here's 30, here's 31, 30.118144 is somewhere about here. I have to do at least this. If I only go this far, I haven't reached this threshold, right? This is the threshold that I have to reach. If I only hit 30, I haven't reached the threshold yet. So what I have to do is I have to go up to the next whole number, because I can't survey 0.118144 of a person. I have to go up to the next whole number and say 31 people. Okay. So this isn't a weird rounding thing where you look at this and you say, oh, I must have plugged something in wrong. Or, you know how sometimes like your z-score, like if you go more decimal places or something, then you get a slightly different answer and you're like, oh, that's close enough. That's not what's happening here. What's happening here is you get this number and you have to go up to the next whole number because you are dealing with a sample size. You're dealing with the number of people, and I can't take 0.118144 of a person, so I have to go up to the next whole number. Okay. All right. Give me a second. I'm going to get a drink. Okay, the grade point average collected from a random sample of 150 students produced a mean of 2.86. Assume that the population standard deviation is 0.78 and construct the confidence interval for the population mean, mu, if your confidence level is 0.98. Okay, so let's go through and start labeling a bunch of these things. So random sample of 150 students. Okay, that random sample produced a mean, so that's a sample mean of 2.86. Almost missed that decimal there. Also, I would have caught it eventually because we're talking about grade point averages. It doesn't make sense to have a GPA of 200 something. Okay, assume the population standard deviation is 0.78. Often that's like done from previous studies or something. They want us to construct a confidence interval for the mean if our confidence level is 0.98 or 0.98. That got messy. All right. So our confidence interval is that the true population mean falls somewhere in between our sample mean plus the error and our sample mean minus the error, right? So if we're doing this by hand, then we're calculating the error using this formula, right? So another formula to memorize. Your z-score is the one that corresponds to your confidence level, right? So you would calculate your margin of error by hand, and then you would take it and you would add it to your sample mean. And then over here, you would take it and you would subtract it from your sample mean, and that would get you your two numbers, right? That's how you would do it if you were doing it by hand. We're not going to do it by hand. We're going to do it in the calculator, where we go stat, tests, and because we have a population standard deviation, we're going to go to number 7, which is z-int. So we go stat, tests, and then down to number 7, not interval. It actually does say the whole word, interval. This is a z-interval because we know our population standard deviation, right? If we didn't know it, if we instead had a sample standard deviation, we would be the next option down, t-interval. But we're at z-interval. Okay, so we make sure it's on stats and not data, and we plug in everything that we know. We know that our population standard deviation is 0.78. Our sample mean is 2.86. Our sample size is 150, and our confidence level is 0.98. And we calculate. So if we take those numbers and round them to 2 decimal places, that's how we get 2.71 to 3.01. So what that's saying is we can say with 98% confidence that the true population mean lies somewhere between 2.71 and 3.01. Okay? So you can either write it like this, or you can write it just with the parentheses like they have there. But if you are going to write it with the parentheses, don't forget that this is what that actually means, right? Your true population mean lies somewhere between this and this. And we can say that with 98% confidence. Okay. All right, construct a 95% confidence interval for the population mean. Assume it has a normal distribution. A sample of 20 college students. Okay, good thing they told us it was a normal distribution because that sample size would be too small otherwise, right? Remember, the requirements are that it has to be either 30 or more, or it needs to be normally distributed. It's great if it's both, but it needs to be at least one of those things. So since it wasn't 30 or more, then it needed to have a normal distribution. Okay, so a sample of 20 college students, that sample had a mean annual earning of 3120, and that sample had a standard deviation of 677. And they said that they wanted the confidence level to be 95%. Okay. All right. So again, we're going to have the calculator do this for us, right? So we're going to go to stat, we're going to go to tests, and like we said just a minute ago, this is a t interval, right? If you know your sample standard deviation, but not your population standard deviation, you have to use a t-score, your t interval. So we go stat, tests, number 8, t interval, and we plug everything in. And also what's nice is that, let's say you accidentally select the wrong one, right? Let's say you don't remember if this is supposed to be a Z or a T. If you go into the other menu, it's going to ask you for a sigma rather than an S. So as long as you've labeled these things correctly by hand, then that will prompt you to say, oh, that's not the symbol that I was expecting to find there. I must be in the wrong menu. Oh, that's right. This is supposed to be a Z score instead of a T score. That would have been used if you were doing it by hand. All right, so what we're saying here is that the true population mean is somewhere between 2803 and 3437 if we round to whole numbers, which they did in this one. And we can say that with 95% confidence. All right. Construct a 95% confidence interval for the population mean. Assume it has a normal distribution. A random sample of 16 fluorescent light bulbs. Maybe I should have started with my confidence level is 0.95. Anyway, okay, 16 fluorescent light bulbs. That sample has a mean life of 645 hours, and that sample has a standard deviation, so it's a sample standard deviation of 31. Okay, so again, we go stat tests, and we select number 8, the T confidence interval, because we have a sample standard deviation, not a population standard deviation. And that's how they're getting those numbers. So again, you just make sure that you're rounding to the same number of digits that they ask you to. So we can say with 95% confidence that the true population mean falls between 628.5 and 661.5. Okay, a survey of 280 homeless persons showed that 63 were veterans. Construct a 90% confidence interval for the proportion. They've come out and said the word proportion. We don't need to guess what kind this is. They've told us it's a proportion of homeless persons who are veterans. Okay, so a survey of 280 people, that's our N, 280, showed that 63 were veterans. That's an X value, right? Now, keep in mind that P hat is X over N. So if you're in a menu that requires a P hat, you put your X over N. Or if it's the menu that requires X and you have P hat, you can just plug in your P hat and your N into this equation to find X, right? Okay, so we have N, we have X is 63. We want to be 90% confident, so 0.90. All right, so we're looking at the proportion. That's supposed to be a capital P. Population proportion. Okay, so if we know, if our population standard deviation is known, that known, then we're using a z interval. If our population standard deviation is unknown, so we have sample standard deviation instead, then we use a t interval. And if it is a proportion, we use 1 prop z int. Right? Stat test, 1 prop z int, which is a. And we plug in what we know. Our x value is 63, our n is 280, and our confidence level is 0.90, or just 0.9. All right. Now it will spit out your p-hat for you. Sometimes you already had that and you had to work backwards to give it the x. But yeah, so it oh, I wrote that too close. So they want us to go to 3 decimal places, so that's how they're getting 0.184 and 0.266. So we can say with 90% confidence that the true population proportion of homeless people who are veterans is between 18.4% and 26.6%. Okay, a researcher at a major hospital wishes to estimate the proportion of the adult population of the United States that has high blood pressure. How large a sample is needed, right? What's our N? That's what we're trying to find. What's our sample size? How large a sample is needed in order to be, we've got a 98% confidence level that the sample proportion will not differ from the true proportion by more than 3%. So our error is going to be 3%. We need to write that as a percent, like as a decimal, right? Okay, so again, I'm going to give you guys the PDF that has all the formulas, but you've got to know that when you're dealing with proportions, the formula for your sample size is you do your p hat times your q hat, you do your z sub c over e, and you square that, okay? Remember, your z sub c is based on the confidence level, right? Okay, so we are 98% confident, okay? So we have the area is 0.98. We want the positive corresponding z-score. You always take the positive one in these. So if I have an area and I want a z-score, that's the inverse. So we go second vars, inverse norm. The area is 0.98, and we have to make sure that we're telling them that that's the center area. If you want to do this using the table instead, then you would say, okay, well, the middle area is 0.98. So both of those together are 2%. So each one individually is 1%. So the area to the left of the z-score is 98% plus 1%, which is 99%. So you look up an area of 99 to get that your corresponding z-score is z sub c equals 2.33 if I go to 2 decimals here. Okay. All right, so we have our z-score, okay. So actually, let me write that over here. Let's kind of organize everything we need here. It's going to be 2.33, and we use the positive one, not the negative one. Although it wouldn't really matter because we're squaring it. When you square a negative, it becomes positive. All right, so we have our z-score. We have our margin of error. What we don't have is our p hat and our q hat. So you have to remember that if they don't give you a p hat or a q hat, you have to assume that p hat equals 0.5. And since p hat is the complement of q hat, that means that by default, q hat is also 0.5. So we're going to plug those in to this formula as well. And I like to use parentheses everywhere just to be extra sure that everything's good with all the order of operations. Doesn't matter quite so much in this one, but you just always want to be careful. Okay, so let's plug that in. So I'm not going to do the parentheses on these first ones. Okay, so I'm getting 1508.0277778. And again, this is a sample size. I can't have 0.02, or if I round it, 0.03 of a person. But this is my bare minimum threshold that I have to reach, or ideally exceed. But even if all I wanted to do was reach it, I couldn't stop at 1508 people, 1,508 people. I couldn't stop there because I would not have reached the threshold. And since I can't survey 0.03 of a person, I have to go up to the next whole number of 1509. Right? Okay. Okay, a researcher wishes to estimate the number of households with 2 cars. How large a sample size is needed, right? So what's our N? That's what we're doing here. What's our N? In order to be 99% confident. So we have a confidence level of 0.99, that the sample proportion, so they're telling us it's a proportion, will not differ from the true proportion by more than 3%. So our error can't be anything but any more than 3%. Now, they are telling us that a previous study indicates that the proportion of households with 2 cars is 18%. So they're saying, hey, a previous p hat was 0.18. So we can find q hat because it's 1 minus p hat. So that's 1 minus 0.18, which is going to give us 0.82. So remember, the formula is p hat times q hat times the z-score that corresponds to your confidence level over the error squared. Okay, so the z-score that corresponds to the confidence level, if we have a 99% confidence level, we're going to go inverse norm because we have an area and we want a z-score. So I'm going to go second vars inverse norm. The area is 0.99, and that's the area in the center. And I'm going to take the positive one of that. So this z-score right here is 2.58 if I go to 2 decimals. Okay. So now I'm going to plug everything in. My p hat is 0.18. My q hat is 0.82. My z-score, if I go to 2 decimals, is 2.58. My margin of error is 3%,